Okay, welcome back, guys. Still, we are working on a numerical example and practical example about marginal utility. And this time, we are working on example number 5, which is the perfect substitute utility function. Now, let's find out the marginal utility of x and also the marginal utility of y for this perfect substitute utility function, which is utility as a function of x and y is equal to ax plus by. So now, without wasting our time, let's solve it. So then, marginal utility of x is the partial derivative of this utility with respect to x. Then the partial derivative of this function with respect to x is just a. Just a, because the derivative of ax is a. Here we don't have any x, so and also the marginal utility of y is equal to the partial derivative of y with the partial derivative of utility. Sorry for that. The partial derivative of utility with respect to y, and it's equal to b. So as you see here, in contrast to the marginal utility of CS utility function and also Cobb-Douglas utility function, here the marginal utility of x and the marginal utility of y is constant, it's fixed. It does not depend on how much x and y we already have. So the marginal utility of x is equal to the coefficients of x, and the marginal utility of y is equal to the coefficient of y, and it's already a fixed number. So the value of marginal utility of x and y in case of this perfect substitute utility function does not change over the indifference curve. It's fixed in any point of the indifference curve, and it's equal to the value of the coefficients of x and the coefficients of y, a and b. So now, without wasting our time, let's solve a numerical example of perfect substitute. Let's write down as an example number 6. And in example number 6, let's suppose that we have 2x and 3y. 2x and 3y. So now, let's find out the marginal utility for this perfect substitute utility function, which is our utility is equal to 2x plus 3y. Then the marginal utility of x is equal to the partial derivative of utility with respect to x, and it's just simply 2. Just simply 2. Let me write down with another color. It's just simply 2. And the marginal utility of y is equal to the partial derivative of utility with respect to y, and it's just equal to 3. As you see, the marginal utility in case of perfect substitute utility function is a fixed number. It's just 2 and 3. With 2 is equal to a and 3 is equal to b. A is the coefficient for x and b is the coefficient for y. It's just a fixed number. It does not depend how much x and y already we have in a consumption bundle. Let's solve the marginal utility for the quasi-linear utility function in the next video. So see you guys in the next video. Thank you so much. Don't forget to subscribe my YouTube channel in order to have more clients and more students and more fellows to watch these videos and to learn something about microeconomics.